Ever take a look at a circuit board?
And wonder how they cram all that tech into such a tight space.
We're talking intricate designs.
Tiny components.
It's a whole world of complexity in PCB design.
It's true. Even with sophisticated software like KiCad, there's a constant push for more streamlined design processes. And that's where automation comes in.
And that's where KiBot enters the picture, right?
This open source tool, formerly known as KiBot, seems to be making waves in the world of KiCad. From what I understand, it can automate some seriously complex tasks, like generating 3D models directly from your designs.
That's one of its key features. KiBot takes KiCad's existing 3D capabilities and elevates them through integration with Blender, a professional 3D modeling software.
So it's not just about making the model look pretty. What are the tangible benefits of that increased fidelity in a design workflow?
The difference in quality can be significant. Imagine being able to identify a potential component clash or a clearance issue directly from the 3D model during a design review, potentially saving hours of rework later. It also helps communication with manufacturers, providing them with a clearer visualization of the final product.
That makes a lot of sense.
Yeah.
Now, the documentation also mentioned KiBot evolving from a tool called KiBot. Can you shed some light on that transition? What prompted the shift towards a more automation-focused approach?
KiBot emerged back in 2018, initially designed for generating high-quality plots from KiCad designs, but in 2020, with the involvement of a new developer, the project underwent a significant transformation, ultimately leading to its renaming as KiBot with version 0.5.0. This marked a deliberate move towards a broader vision of automation in PCB design.
Okay, so it sounds like a classic open source story. A project takes on a life of its own, driven by the community's needs and a shared passion for innovation.
Precisely. And that open source aspect is crucial here. It allows for a level of transparency and collaboration that's often missing in proprietary software.
Speaking of collaboration, something else caught my eye, the mention of CI/CD integration. I'm more familiar with that term in the context of software development, not hardware design. What does that look like in the world of KiBot and PCB design?
It's a fascinating application of a software development practice to hardware design.c/CD, which stands for continuous integration/continuous deployment. It's about automating the process of integrating code changes, running tests, and deploying software. KiBot adapts this concept for PCB design, essentially creating a system where design changes can be automatically validated and verified.
Constantly checking your work and making sure everything is in order.
Exactly. It introduces a new level of rigor and efficiency to the design process, ultimately leading to more robust and reliable hardware.
It sounds incredibly powerful. But for someone who might be new to all this, especially the software development side, it's easy to get lost in the technical jargon. Could you break down the practical benefits of this CI/CD integration for, say, a team of engineers working on a complex PCB design?
Absolutely. Let's say you have a team spread across different locations, all contributing to a single PCB design. Each time someone makes a change and pushes it to the central repository. KiBot can automatically run design rule checks, ensuring everyone is adhering to the same standards. This prevents inconsistencies and potential errors from creeping in.
Streamlining collaboration and reducing the back and forth, that often slows down team projects.
Exactly, and because these checks are automated, they happen much faster than manual reviews. This means potential problems are flagged early in the design cycle, saving valuable time and resources. Imagine catching a design flaw that would have required a complete board respin. With KiBot's CI/CD integration, you're more likely to catch it before it gets to that stage.
That's a powerful example of how automation isn't just about speed, but also about improving the overall quality and reliability of the end product. Now, diving deeper into the documentation, I came across another term that piqued my curiosity: Docker. It seems a bit out of place in the context of PCB design. Could you explain how it fits into the picture?
Docker is a game changer when it comes to accessibility and ease of use. Imagine it as a virtual container that encapsulates KiBot and all its dependencies, creating a self-contained environment where it can run smoothly, regardless of your operating system or existing software.
So, whether I'm running Windows, macOS, or Linux, I can use KiBot without compatibility issues.
Precisely. No more wrestling with complex installations or dependency conflicts. This is particularly beneficial for teams with diverse setups, as it ensures everyone is working with the same consistent environment.
That's a huge advantage, especially for teams collaborating remotely or working with external partners. It removes a significant barrier to entry.
Exactly. It democratizes access to powerful automation tools like KiBot, making them readily available to a wider range of users.
It's incredible to see how open source projects like KiBot are pushing the boundaries of what's possible in PCB design. As we wrap up, I'm curious to hear your perspective on the broader impact of this trend toward automation in the field. What does the future hold for PCB design? And what role do you see tools like KiBot playing?
It's an exciting time to be involved in PCB design. I believe automation is going to reshape the industry in profound ways. We can anticipate faster design cycles, more complex designs becoming manageable, and a greater emphasis on collaboration and agility. Tools like KeyBot will be at the forefront of this transformation, empowering designers to focus on innovation and pushing the boundaries of what's possible.
It sounds like we're on the cusp of a new era in electronics design, one where the creative potential of engineers and designers is amplified by powerful automation tools. If our listeners are eager to explore KiBot further, where can they go to learn more and perhaps even contribute to this evolving project?
The KeyBot documentation is a great starting point. It's surprisingly accessible and well-structured. The KiACAD community forums are also incredibly valuable, offering a space to connect with other users, seek help, and share insights. And of course, the beauty of open source is that anyone can contribute to us, whether it's through code contributions, documentation improvements, or simply sharing your experiences with the tool.
A true testament to the power of community-driven innovation. Well, there you have it. We've journeyed through the intricacies of KiBot, from its humble beginnings as KeyPlot to its emergence as a powerful automation force in the world of PCB design. We've explored its key features, its potential to transform workflows, and the exciting possibilities it unlocks for the future of electronics design. If you're ready to dive into the world of automated PCB design, KiBot offers a compelling and accessible pathway. Until next time, happy designing.